Hello guys, in this video we look into another subtopic that will be covered in your heat, okay, in your heat topics. So we look into the mercury thermometer. So before this we had looked into the thermal equilibrium, and then how can we calibrate a thermometer without scale, and then the difference between heat and temperature. So in this session, I would like to show you, okay, a little bit, or to tell you a little bit about the thermometer that we normally use in our lab, which is the mercury thermometer. So here you have this mercury thermometer in the notes given. So it consists of a thin wall glass bulb, okay. So at the end of the one of the thermometer, there is a thin wall glass, okay, which we call as bulb, also known as berbuli in Malay, right? Okay, so it made up of a very thin wall bulb. Okay, later we will know why it is made by thin wall glass. And then inside there is mercury. Okay, we have mercury inside in this bulb, and then it will attach to the uh, to the to the stem of the thermometer. Okay, so this one we call it as capillary tube. So the stem of the thermometer, we call it as capillary tube. So the specific thermometric property in use in this thermometer, as we learned before, is we use the property of the mercury which expand, okay, where it will expand with with temperature. So when the temperature increase, okay, let's say we put something hot near the thermometer with fire, okay, and then what will happen? Okay, heat will be transferred to this thermometer, and then it will pass through the thin wall and then get into the mercury. So what will happen to the mercury? So based on this property, the mercury will expand. Okay, let's say we don't have or maybe at room temperature, okay, it just stop here, okay, just stop here. But after we put the thermometer near the hot object, what will happen? It will start to expand, and there is no other way for this mercury to expand except through the capillary tube. Okay, there is no other space except through the capillary tube. So it will expand until when? Okay, until the thermometer and the fire reach the thermal equilibrium, then it will stop expanding. Okay, so that is how the mercury thermometer works. So the sensitivity of the thermometer can be increased by first using a thinner wall glass bulb. So why we say that by using the thinner glass wall bulb, it can increase the sensitivity. So just imagine if you have a thermometer, okay, thermometer. So first one, we use a very thick bulb. So that's mean the mercury only can uh, occupy this space. Okay, occupy this space. And another one, we make another thermometer, but this time the wall of the bulb is thinner compared to the previous one. Okay, So here is the capillary tube. So you can see here, this is the thick capillary bulb, and this another thermometer with thinner uh, thinner bulb. So what is the difference? Okay, when we put both thermometers at same source of heat, okay, same source of heat, okay, heat will be transferred to the thermometer. But since this wall is thinner compared to this one, so heat can travel faster towards the mercury compared to this one. Should be there should be more resistant for the heat to reach the the mercury. So that's why here will be less sensitive. That means when we put to the hotter object, it will take time for the mercury to expand. Okay, but when we use a thinner bulb, okay, it will expand easier, a lot easier compared to this thick bulb. Okay, that is how a thinner wall glass bulb can help to increase the sensitivity of thermometer. Okay, another method to increase the sensitivity of the thermometer is by reducing the diameter of the capillary tube. Okay, so first, just imagine we have a thermometer here. Okay, so one with a bigger capillary tube. Okay, bigger capillary tube. So this is the bulb. This is the bulb. Another one is with a thinner capillary tube, but with same size of bulb. Okay, same size of bulb and same size of stem. Same size of the thickness. Only the size of diameter is different. Okay, so we put mercury inside here. Okay, inside the bulb and the capillary. Okay, so what will happen if we bring another source of heat? Okay, source of heat near the thermometer. Again, heat will be transferred. Okay, same thickness, so it will reach at same time to the mercury. Okay, and at the same time, okay, the mercury will start to expand. Okay, the rate of expansion of the mercury will be the same, but since the diameter of this capillary, okay, is different. Okay, that's mean, let's say this mercury want to expand only 1 centimeter cube, so it will raise until here. Okay, what about this one? 1 centimeter cube, since the diameter is very small or smaller compared to this one, so 1 centimeter cube will be higher. Okay, will be higher compared to this one. So this is how the by reducing the diameter of the capillary tube can increase the sensitivity of the thermometer. Okay, so mercury is used in thermometer. Okay, now we look into why the mercury is used in our thermometer. Why don't we use water and other materials? Okay, so first, it has higher boiling point. Okay, it has higher boiling point. That means it won't easily melt, and it won't be easily solidified or become solid, and it won't easily become a gas. Okay, and then it does not stick to the glass. Okay, it does not stick to the glass. That's mean uh, what they call it, what does it the name of the force, okay, I forget the name of the force. Okay, but it can move easily, raise upward or move downward when it expand and contract. And then it's opaque. Okay, the property is opaque. That means light cannot pass through, so we can observe easily the level of the mercury. If we use water, okay, water is transparent, so we cannot cannot see easily the level of shown by the water. And then expand and contract uniformly. Okay, so due to its property, so it expand, okay, it expand and contracts uniformly. So that is all about the thermometer that we use in our lab, which is the mercury thermometer. Okay, so that's all. Thank you.